Okay, we're going to get started with our math. We're going to begin in Unit 2, and this is number theory that is going to deal with divisibility, telling whether or not a number is divisible by another number, whether you can divide it equally. We're also going to talk about factors, and we're going to talk about prime factorization and greatest common factor. And this unit is actually going to spill over into Unit 3 a little bit, because towards the end of this unit we'll get into multiples and start talking about least common multiple, which will take us into Unit 3 and go into fractions, simplifying fractions, adding, subtracting, multiplying, dividing fractions, decimals, percent, and ratios. And ratios work a lot like fractions that you will see. So all of this is going to start to flow together, and not just flow throughout this unit, but flow into Unit 3. Okay, so this is very important for us to make sure we keep up with. Okay, now we're going to go over the activities that we did yesterday to help us prepare with it. And I'm going to start with talking about the flip chart. We're going to get to this chart in just a second, which is how we're going to remember what our prime numbers are. But I want to go over the flip chart very quickly to remind you of the rules, your divisibility rules, and why they are important, and why it's important that you have completed your flip chart. Okay? These are resources that you can keep to help you throughout this unit. Okay? When we get into finding factors and finding the greatest common factor, and even when we get back into dividing, if you know your divisibility rules, it will help you to find those numbers faster. Okay? That's what divisibility rules are for. You can look at that number and say, well, if this rule applies, then it's divisible by 2 or 3 or 4 or 5 or 6 or 9 or 10. Okay? So, just to review over those rules, we said for Rule 1, what did we say about the rule for number 1?
It's divisible.
As far as divisibility, our divisibility rule. Do it. All numbers are divisible by 1. Guys, if you do not know that, if you can't say that off the top of your head, what should you do? Look down at your chart. Everyone should have you need to have your divisibility chart out. Okay? You need to have your charts out. If you don't know those rules, you need to be looking at those rules. I still do not see everybody's chart out. Yes.
What about the people who don't go with that?
Well, you have to get you one made, okay? Now, the rule for 1 says all numbers are divisible by 1, okay? The rule for 2. What's the rule for 2? Let's raise our hand.
If the last number ends in 0, 2, 4, 6, or 8, it's divisible by 2.
Okay? If the number ends with a 0, a 2, a 4, a 6, or an 8. So if it's an even number, that keep your feet off of my stuff you're moving. If it's divisible by 2, it's an even number, which means it ends with a 2, a 4, a 6, an 8, or a 0. Okay? What about 3? What's our rule for 3? If the sum of the digits, okay? We're going to take a closer look at that in a little bit. They're saying if you have a 3-digit number, you add those three digits together, and if the answer you get can be divided by 3 evenly, then that 3-digit number itself can be divided by 3. Okay? Fours. Okay, if the last 2 digits form a number that's divisible by 4, you can have a 7-digit number, but if the last 2 digits of that 7-digit number are something like 16 or 08 or 32 or any numbers that is divisible by 4, then that entire number itself is divisible by 4. Okay, 5s. If it ends with a 0 or a 5. Okay? Now, on the activity, the flower activity, remember it had the 2 and a 5 and 10. You have to start noticing those connections. We said if it ends with a 0, it can be divisible by 2. And if it ends with a 0 or 5, it's divisible by 5. So that means if it ends with a 0, it's divisible by 2 and 5. Okay? We're going to have to make connections sometimes with those numbers. Okay? 6.
If the number is divisible by both 2 and 3.
If it's divisible by both 2 and 3, it's divisible by 6. Which means we have to take the rule for 2, ending with 0, 2, 4, 6, or 8, and the rule for 3, and add our digits up and see if the answer is divisible by 3. And if both of those apply, then it's also divisible by 6. Okay? It's about combining those rules, and that's what the sheet, the visibility picture, that's what you were getting practice doing. Okay? And we're gonna talk about that a little bit, and then we're gonna make sure that we get all of that completed and turned in. Okay? 9.
If the sum of the digits is divisible by 9.
Okay, if you add the numbers up and the digits are divisible by 9, then the number itself is divisible by 9. Is 9 divisible by 3? Yes, so that means if it's divisible by 9, it's also divisible by 3. Okay? If it's divisible by 3, is it always going to be divisible by 9?
No.
No. Okay? So we want to think about that when we're doing our divisibility rules. And 10.
If the last number ends with 0.
If the last number ends with the 0. So we've heard 0 for how many? 3 of them. 2, 5, and 10. Okay? So if a number ends with a 0, it's divisible by 2, 5, and 10. If a number ends with a 6, is it divisible by 2, 5, and 10? No. Okay? So, and the reason I'm saying that is because of that activity, that divisibility activity as well. We had a couple of issues with that, and I want you to see how that was supposed to work. Okay? Now, knowing your divisibility rules, when you're asked what your factors are, the first thing you need to do is think divisibility rule. You look at that number and see if one of those apply. If it does, that gives you the first factor. Okay? And then you can use your use division to find other factors. So that's why divisibility rules are important, because they will give you the first factor when they ask what factors are. Guys, we are not up and moving about without permission. If we have trash to throw away, we throw it away at the end. If it's pencil shavings, you should have a Ziploc bag, okay? We cannot move around because it distracts everybody else. They're watching you instead of watching me. Okay, so one thing that's going to help us is our divisibility flip chart. You all need to make sure you have yours completed with the rules and an example. Okay, the next thing we're going to look at are prime numbers. What this is going to help is because we're going to move into prime factorizations. So those are factors, which divisibility rules can help us find factors, but we also are looking for the prime factors only. So we're looking for the factors that are prime numbers. And the way we're going to be able to know that is because we're going to go through this activity that I was given. I'm going to go over it with you. We're going to check it, make sure you have all the correct prime numbers. There are 25 prime numbers between 1 and 100. And basically, guys, you're going to have to be familiar with those prime numbers. This is why I gave you this activity. You have it to look at anytime, getting familiar with those numbers, okay? So we're going to go through this. And if you haven't completed it, you need to follow along with me. It says number 1 is a special case. It is neither prime nor composite. Put a box around number 1. Okay? That's very important. 1 is neither prime nor composite. That's important to us because when we do prime factorization, when we're breaking our numbers down, we can't keep going to 1 because 1 is not prime and 1 is not composite. So it should not be part of our answer at all. The next one says number 2 is prime. So circle number 2. And it says cross out all numbers divisible by 2. What does our divisibility rule say about 2? What numbers are divisible by 2? Okay. All even numbers are divisible by 2. So you need to go through here and mark out all the even numbers. You just follow along the best you can. There's only a couple prime numbers. Just make sure you mark what your prime numbers are once you're done, okay? That's going to take out half of this list, so that should help us to get those, to be able to remember what these prime numbers are going to be. Okay? So we crossed out all of the even numbers. It says number 3 is prime, so circle 3. And cross out all numbers that are divisible by 3. Okay? What was that rule for 3? If we add the digits together and it's divisible by 3. Okay? First of all, for the single digits, we can't add them together, so we just have to look and see. 6 is already gone. The next one is 9. Okay? 12 is gone. And the way we know 1 plus 2 gives us 3. So that's how the divisibility rule works. Okay? 1 plus 5 gives us 6. Is 6 divisible by 3? Yes. So anytime a number is, when you add the digits up and it's divisible by 3, then you mark it out. Okay? 21. 2 plus 1 is 3. Okay? So we're going to go through and mark out all the 3s. And we can also, an easy way is just to count up by 3s. 21, then 24. 2 plus 3 is 5, so that's not divisible, okay? Then 24, then 27, then 30, 33, 36, 39, 42, 4 plus 2 is 6, which is divisible by 3. 45, 4 plus 5 is 9, which is divisible by 3. 48, 51, 5 plus 1 is 6. And that's one of those numbers that I actually had somebody ask me yesterday. They said it was prime, and they were asking me if that was true. So we put the divisibility rules in place and saw that 5 plus 1 is 6. Okay, 54, 57, 5 plus 7 is 12. Is 3 divisible by, is 12 divisible by 3? Yeah, so 57 is not prime. Okay, 60, 63, 66, 69, 72, 75, 7 plus 5 is 12, okay? 75, 78, 81, 8 plus 1 is 9, okay? 84, 87, 8 plus 7 is 15, and is 15 divisible by 3? Yes. 90, 93, 96, 99. Okay? So that has taken care of all of the 3s. Says the next uncrossed number is 5. So circle 5. And then cross out all the multiples of 5. Okay? 5, the divisibility rule says it ends with a 0 or a 5. So
we're crossing out all the numbers of the 5, and then everything on the 0 is on crossed out.
right. So all the zeros are crossed out, so we just do everything on the 5. 15, 25, 35, 45, 55, 65, 85, and 95. Okay? Then it says circle 7, because it's prime, and cross off all the multiples of 7 that are already not crossed out. Okay? So we do 7. 7 times 2 is 14. 7 times 3 is 21. 7 times 4 is 28. 7 times 5, 35. 7 times 6, 42. 7 times 7, 49. Okay, 7 times 8, 56. 7 times 9, 63. 7 times 10, 70. 7 times 11, 77. 7 times 12, 84. We still have to keep going up to 100. So if we add 7 to 84, we will get 91. And 91 plus 7 is 98. So we have all of the 7s. Now it says any number that are left are prime, so circle them. So we have 7, we have 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, and 97. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Okay? So all those numbers that are circled are your prime numbers. So guys, you see how your divisibility rules work? If the number is not divisible, all we used were 2, 3, 5, and then 7. And after using those rules, everything else left over were prime. So if they ask if a number is prime or composite, just think about those basic rules. You don't even have to think about all of them. Okay? You can double check with some of the other ones just in case, but if a number is divisible by 4, it's also divisible by what? 2. So 2 takes care of that. If the number is divisible by 10, it's also divisible by 5 and 2. So that takes care of that. If a number is divisible by 9, it's also divisible by 3. So it takes care of that. If a number is divisible by 6, it's also divisible by what? 2 and 3. So 2, 3, 5, and 7 pretty much takes care of all of them. If it's not divisible by those, it's probably prime. Okay? So those are the things to remember there. Now you can either go that direction or you can attempt to memorize these 25, because you may see a couple numbers past 100, which you can use your divisibility rules. But if it's not past 100, then your basic chart should help you. Okay? Any questions about that? Make sure you have your correct prime numbers circled. Guys, if you didn't do it correctly the first time, my advice to you is just to write down the numbers that are circled. Write down your prime numbers and get familiar with those. Okay? Any questions about that?